Okay, we officially start with this class. Anytime, please interrupt me if you have something to ask or anything to say. I continue pushing you to use the forum, open it. Some of you have already asked questions and I'm replying questions. I think that to have public questions and public answers is really important for working. And I'm just pushing you to upload your solutions to access to homework. Don't be shy, don't be timid. So everywhere in the network, there's a lot, there is a plenty of persons who publish their experiment, the small codes with errors and ask for help to other programmers and so on. So the coders community is made of great publicity in their codes. So I know already that some of you has solved one of the problems, the dining philosophers, and I've asked him not to publish immediately, just to wait for some, for example, tomorrow, because I want that you learn personally on that problem. It's an important problem from a theoretical point of view and from the point of view of the solution involved. So please keep on thinking on, like the philosophers on it. And as soon as it would be, it's time to do that, one of you or more than one of you will publish the solution. Okay, so please publish your solution, your ideas. Well, finish all these premises are over. We start with the first topic. The first topic is a theoretical topic, so the first glance to sockets. To open the, well, I have to share the screen, and I think I have already opened the, yes, it's here. Sockets. I assume that you see the slide. So we will talk about just a general idea of sockets without entering into details for half an hour or less. Then I will propose you some new exercise, new problems to discuss in groups, not just in general, as a general design of the solution, not going into the details of not coding and not pseudocoding, just to define which element, which are the system calls, which are the methods to solve those problems. There are typical problems of the automation system, and of course, including robots. But now we start with the sockets. Well, sockets. Socket is a common name. And socket is on the wall, and you plug into a socket. So the idea is to make processes to communicate using a primitive that is a metaphor of a socket, plug into a socket. The principle is that communication between processes on same or different machine. That's the novelty. So far, we knew files with file descriptors, defined by file descriptors. We knew pipes, unnamed pipes with related file descriptors, named pipes with file descriptors for defining them. and so you see that the concept of file descriptor is central concept, file descriptor. And we will keep on using the file descriptor. So I told you in the beginning that the concept of an abstract file is central concept for gluing all processes together in POSIX. So, and also in this case, you will see the role of the concept of file descriptor, FD. They are an old concept, well established concept. They started in the early 80s of the last century, and were developed. They also today they are called in jargon Berkeley sockets, because Berkeley University of Berkeley made a version, or today we call a release, or a version of Unix, including for the first time the concept of sockets. Now sockets are POSIX, but not only POSIX. Sockets are available in all operating systems. Someone is calling me, but I don't answer. Well, sockets mix the idea of IPC and networking. Networking means that there is a communication network, digital communication network, of course. For example, internet. Most part of sockets today are used in the networking system, that is internet networking system, also in local networks. Local networks, in any case, the same protocols and the same definitions of using internet. Also in a local network inside a car, for example, or a local network inside a group of robots, or inside a mobile robot, or a welding robots in automotive factory, for example. So the networking is a standard that has nothing to do with sockets per se. Is a way of making machines communicate. And the idea is that if you want to make process communicate, here are processes, you can use the network to make processes communicate each other. If you use the network, that is a concept that was born separately from the operating system, or each operating system itself, as a way of making processes to exchange data with a suitable suite of protocols, you can make processes communicate each other. So you use the network as a support for IPC, inter-process communication. There is something similar and something different from other IPC we know. For example, named pipes or named pipes. Some concepts are similar, some concepts are different. Sockets are bidirectional. This is similar to pipes in general. Sockets are endpoints, so they evidentiate the name of the and use the concept of address in internet address for making defining the endpoint. And socket uses the concept typical of the of networking. A process that we want to make connected to another process is an application, is called application in the network language, and uses for communicating with another process another concept in networking that is called the transport layer. Layers are, well, the standard that defines the networking is composed by different layers of physical, the lowest layer, so abstraction is growing upwards. This is the lowest level in the communication system is the physical level. So the standard for cables, for plugs, the voltage of signals, and so on. And in different layers, we have different concepts. For example, addresses, and the transport layer is. I'm sorry with the telephone. I hope that at home someone will answer the telephone. Yes, they did. The lower layer is the layer in the standard of the network that is whose responsibility is just to define addresses of the nodes to be connected, like phone numbers in the telephone network. The concept of packets in which the communication is constructed. So if you have a flux of data, a stream of data, like in a regular file in which data are put on blocks on the disk, in a network communication, data, the flow of data is composed by several blocks called packets. Let me recall here, packet. Packets are single unities of data that are transmitted through the network. Another concept related to networking is called the packet switch, but it doesn't matter, so we don't use those details. And packets are supported, distributed along the network from the source to the destination. The most abstract layer in the structure, that is the model of a networking system, of internet in practice, the highest level is the application level. And in this case, the application is just the process you are running. The process wants to send data to another process somewhere in the network. So asks all the layers to pick up the message, to build all the packets necessary to support the message, to define which is the address of the final destination, and gives all these elements to the lowest level until the physical level. The physical level may include wireless link and so on, but is so the physical meaning or fiber. So anything is able to code your information. So socket is so important because 30 years ago, some scientists decide to put together the concept of processes, communicating processes, and networking for communication. The effect is is really important, the huge effect. Remarks. A process can plug unplug. What do I mean? The concept of socket, just you have a plug, you can plug and unplug. So you can access the network and asking to use the network for communicating. After you have finished, so you unplug and stay away and plug into another network or for another purpose. So it's a completely dynamic way of communication. If compared with the dynamic, okay. If you compare with the unnamed pipes that are absolutely static, so you have to define pipes. They're very efficient, but once you have established the pipe for communicating between two processes, you cannot change dynamically. That's the pipe. You can close, but you cannot do anything else. In this case, it's absolutely dynamic. You can plug and unplug in the network, just like a telephone network. Just you keep the hook, you compose the number, and the network makes you in communication with the other party. And when you're finished, you just put down the hook of the telephone. You used to. Now nobody has a telephone with a hook, but well, okay. So this is very important. Another point is inside a machine, or outside. So processes can communicate also inside the same machine, using that makes it seem strange, but you can use the dynamicity of the socket instead of using the staticity of a pipe, for example. Or you can develop processes that communicate each other using a socket inside the machine, just for while you develop and you test the system. But once your process is reliable, you can make the process communicate with other processes outside the machine. So there's no frontier. And that's another really absolutely important point. Another important point is the standard. It's called also the open systems interconnection. Interconnection. OSI, open system interconnection. Open system means that once a manufacturer of a machine, of hardware, or a software manufacturer, software company, a new operating system decided that adheres, so complies, that's this standard, can communicate with any other machine of any other manufacturer. So a socket is also a absolutely important, revolutionary. It allowed a revolution in informatics and computing and communication standards in general, because every machine can talk with any other machine, and in particular, using internet, wired or not wired. Before, and the 80s of the last century, all manufacturers had different standards for making machines talk together. And this opened the market and allowed not only the big growth of the computer and communication market, but also, you know, the progress in general in science and so on. This is OSI, Open System Interconnection. That's the reason why sockets are so important. And every time, in this moment, in this very moment in which I'm talking using Zoom, Zoom uses sockets to connect to the central Zoom server, and you are using sockets for making your local software to connect to the servers of the Zoom network. Sockets are used everywhere, and I think that no operating system, neither operating system nor hardware exists that doesn't have a socket interface, standard interface. Okay, just to have a general idea. Now the concept is simple. You use, so the concept, instead of using the process ID number to identify a process, there is an inner concept. There is a concept of typical of the kernel itself. The kernel itself has a terminology and a standard that gives integer numbers to identify objects inside. In this case, objects, processes, are identified using the external standard, so that the network concept. The network concept is the IP address. IP address, IP stands for Internet Protocol. IP is a very old standard. It was established in the years 60s of last century. So 80 years old. And for example, this is an IP. And that's the IP that we are asking to keep static in your cloud machines, so that the machine will be reachable using this number. There is usually we think of the internet address only with this number, but there is an additional number, 60, here is a 32 bits number that defines the oldest standard for giving the addresses, but it's still in use and widely used, and is the simplest one. But we have also an additional 16-bit that is called the port. We will see after. They're absolutely necessary and an important concept. Roughly speaking, this defines the machine in the word. The machine that I'm using, the computer I'm using now to talk, is as an address, but the port number defines for the same machine the kind of service we will see, and defines a protocol for exchanging data. The machine number, so the IP number, usually is defined by the provider of your connection to internet. In the case of the cloud machine you will use, the provider is Azure itself, so you can choose an IP number. The port service, so this is an external decision. Usually you don't decide which is, you ask for one number decided by the network. The network in particular by the providers of the network, or the authorities or the organization that manages your connection to the network. The port service is defined by you. So that's the concept of socket. That is, I think, is nothing special in per se. It's defined in this way. Is to create a socket in general. So these are sort of pseudocode. Yeah, first to define to ask a system call you must carry out some other operations because you know, you're just connecting to a network. Is not like compiling and executing a process inside your system. You must connect to the network. So it's similar to connecting to the telephone networks. You have to do some steps before you have the connection with your process. The first one is just to ask, and we'll discuss not now, but to ask the POSIX to give you a socket, or to open a socket, to generate a socket. And a socket is a triple: domain, type, and protocol. Domain is the method of identifying the endpoint to the machine. So the simplest what's happening? Okay, the simplest, you will see there are several ways of doing that. The simplest and the most common is the internet domain. So use the standard for defining addresses in internet. Then the type. You have several types, but usually the two types of sockets define the way in which you connect to the other process, to you, the party of your connection. So your process P1 uses a socket, uses the network to connect to the process P2. Okay, the connection is made with the address concept and so on, but normally you have two ways of using the network. You will see, we see in more details, but details the general definitions. So the concepts are really simple to understand. One is a reliable connection. Well, we will see then after a metaphor. If in the postal system, in the mail system, if you send a registered mail, you send a mail, and the mailman makes the receiver to sign that as received, and you have the return receipt. So the sender knows that the receiver has received the mail, and that the register mail. The most common system is use this in the as a type of socket. The socket of this kind, called stream, is a socket that guarantees you that all information is delivered in any case with no errors. The system, the network checks if there are errors, and in that case, it automatically resends all data until they are completely received. So nothing can be lost, and you, sender, have a receipt of the message you have sent. So the most reliable and the most part of communication is of this kind. Is socket is an internet socket, and uses stream. You may understand that if you may ask, well, what is it for? If you lose information, is useless. No, it's not useless, because the sending such kind of information, registered information, so that is safe and guarantees with involves a lot of um, information exchange and controls inside the network. So it's a bit heavier from the point of view of the network, and with the lower speed, for example. There are situations in which you're not really interested that all information is correctly received. You don't want to say that. And so use the so-called datagram. For example, in the digital television is just a connection of sockets, a socket connection, in which the transmitter is not interested in knowing if all receivers have received all the data. Would be also too complex to have an answer by all television sets that are receiving the transmission. And if you lose some frame, nothing. So this is a case in which you have a faster transmission, a faster communication with no, we are not in any case sure of the reliability of the communication. Or if you have a remote control of a drone, for example, this is another case of CPAP. And that the third point, but it's very simple situation, you may choose some different protocol, but usually in origin, this was a parameter for defining a socket, but today is absolutely not important. So even if you have the possibility of changing the protocol, let us say rules used by the transport layer in the network, used to exchange information and so on, there is a default protocol both for stream and for datagram. So in any case, in practice, for creating a socket, you just decide this. And if you want to use a socket in internet, domain is the internet domain. So you have only to choose the type, and in most cases use the stream. So deciding which socket to use is very, very simple. But after you have, so you see, we can skip now because I want to rest and give you a problem on which to work. Just this idea. Port numbers. Port numbers are the part of the address to define the endpoint that you decide. Because in a single machine, there may be several processes, all responding, all connected to the same internet IP number of same address, because the machine has normally just one IP address for all processes. So how can you distinguish and decide? You can identify the single process inside the machine to which you want to plug the connection with a socket. The two parties decide that which is the port, and you decide the port. You have many numbers. Lowest numbers, so from 0 to 1 kilo, are reserved, and for basic service, historical basic services, you cannot. Then there are, you see here, a series of, so you can choose in any case, any kind of port number. There is a part of the address from 1024 up to 16 bits. The authority for networking has registered a certain number of processes that decide which is the port. The most common is the web service. The web service has the port number 80, well-known port, the well-known number, the called HTTP. What is a T? HTTP. The port 80 is connected to the web server from one side, the server side, and the browser uses access to that number to identify the process running on the server that supports the web. There are many other registered means that even if you can redefine by yourself, it's better not to do this because it will give you sort of confusion. Some process will be connected to the wrong side, the wrong party. So it's better to leave this intermediate numbers, there are a lot, for processes well known, in some cases standard in the network, for that respond to known services, even if you can redefine them. This range, there is a big range, is completely free in the sense that the network authority does not register any, you will see a table after. So they are free. You can decide if you want to. In the last assignment, the two students will have two machines, different IP, and when they want to communicate each other, what they will decide together, because they must do a port, one of those ports, and they will identify your processes running. There are also ephemeral services, but I'll tell you some words after. So that's the idea in general. And I wanted to arrive to this point just to justify also the fact that you have to decide which is your machine on the cloud, basing on the IP, but you will decide.
Professor.
Yeah.
I have one question.
Yeah.
In the previous slide, what happens to the port numbers between 49,151 and 49,512?
You mean this? This range?
Yeah, there's a
one?
range that is not specified between both of them.
Okay. They are reserved port. Yes, a reserved port for maintenance of the network in general.
All right. Okay.
So cannot be, should not be used. Should not be used. There is a plenty of ports, and so the only thing you have to do when you decide, when you develop, you design and implement processes connected through the network using sockets, you have to agree with the port number, so that you may have many. This is a scheme very simple, that to show how powerful this method is. A server host has this address that's given by the provider or the organization, but may run many different processes as server, for example. This is a classical example. A web server replies or allows you to connect your socket to the port 80. But another client or the same client may connect to the old port 7, that is the echo server, that is simply just to check if one machine is alive. Echo is just is an echo of the message he receives. It's a very simple protocol. And so you see also in this case that the port in practice as the name is a synonym of port, service, and protocol. Usually in networking, okay, sorry for writing so bad, but in the networking jargon, port, service, and protocol are the same thing. Is a number, 16 bits number that identifies the process inside the same node in it. Okay, that's the initial concept. Tomorrow probably we will arrive as a general glance. We'll arrive to the final concept. So for now, I stop. I want to propose a couple of exercises to discuss, just finding out which are the solutions for solving those exercises, not for necessary to arrive to a pseudocode defining the process for solving that, but just it's a really good result to having discovered exactly which are the primitives to use and the system call to use. Okay, may I stop share? Yes, I did. Questions? I just talked about the general idea. Those of you who come from computer engineering studies or similar probably know already all these things, but not all of you are familiar with this. So I think it's a good idea just to also to discuss the basic concept. So there are also guidelines for you to go in deeper details if you need them. So,
Professor,
yeah,
I have one question. When you were explaining, like sockets sounds a lot like pipes, right?
well, it's
Does it communicate with two different processes?
Probably they are similar to unnamed pipes. You can.
So when it's better to use pipes in sockets?
Well, from logical point of view, obviously there's no difference. You can make two processes to communicate. If you need dynamic connection, it's better to use socket. Dynamic connection means a process can connect to another process, then disconnect, that connect to a different process, and so on. If you want to do that, you need, or it's a good idea to use socket because they're just for that. Another point is that if you want efficiency inside this one machine, and you're sure that your application will live just in your machine, just in one operating system, one kernel, it's better to use pipes because they're more efficient, absolutely more efficient. They don't ask the networking part of the kernel. Sockets, in any case, ask the kernel to access the management of the network, even if they are on the same machine. So it is absolutely less efficient than pipes. But if you want to make processes, to communicate processes, not necessarily in the same machine, socketing is the only way to solve that problem. That's the difference. Okay.
Okay, thank you.
I think that 4 minutes break, and so in the meantime, I will upload the proposal for your discussion. Okay. Recording is on. Good. Two problems. Well, so far, so we know enough concepts to try uh, to model the solution for a real robotic problem. Well, robotic just from a distance, because we just common problem in robotics and in general in automation or in embedded automation systems. So, but I think it's a good idea to do that. One problem. I will share the screen now with, and I will, okay. Oh, okay. Can you see my perfect robot headings? Okay.
Yes, we can see the
Okay,
text.
fantastic.
Yes.
So, well, robot. It's a really simple problem, but is one of the component of the automation architecture. Well, I say robot, but in general is a automation that means real time or embedded system and so on. A common problem is if you have a robotic application made of several processes, I don't give names to the process, it doesn't matter. And here is your kernel, the kernel, no, or kernel. Normally, you need to know that everything runs correctly. So you have several processes running, is a complex concurrent architecture. You want to know, you want to be sure, using a process that is usually called monitor of the system, you want to know if everything goes properly. I hope that you have learned from the metaphor of the dining philosophers that the terrible thing that may happen in a concurrent program is the deadlock. A deadlock may occur in many, many situations. It is very difficult to be sure that never happens. Deadlock is a situation in which all algorithms, all sequential algorithms, all sequential processes, programs cannot go on because each one waits for something that depends on the other processes, but each one does. So everything is stuck on a deadlock. And normally on a real system, there is always a monitor that tries to detect if a deadlock situation is occurred. For deadlocks, and even for starvation. Starvation, we have defined starvation in the dining philosopher metaphor, problem. Starvation is a situation in which computation proceeds, goes on, but solving nothing. In the case of the philosopher, it was a possibility of, was an algorithm in which all philosophers picked up one fork, all the 5 philosophers picked up, for example, the right fork, finding the left fork occupied by the left side philosopher. And so they could decide to put down the fork. So the forks are free, they pick up the fork, and again, they put down the fork. So computation goes on, but they do nothing. That's the concept, one of the possibility, on the possible situation of starvation. Starvation is a situation in which you see that CPU used, but the algorithms does not compute. It's more difficult. Deadlocks is easier. Well, so suppose in a general situation, you have several processes. You are in POSIX, of course. So you have all POSIX concepts. You have signals. You have all system calls. And you have all accessible, all services by the operating system. How? Suppose you want to develop a monitor, and this is a more real problem than the dining philosopher. There is a really abstract metaphor. This is usually, it is really implemented on each system, real system. You have to check if the processes go up. Well, assume that it is good for us, for M, to decide, are the processes running all running? That's the simplest question. M should detect if the processes are running. If not, kill them and reboot. Or stay safe without rebooting, doesn't matter. In any case, you have to, in safety, to terminate all processes. Oh, well, without coding, without even writing the skeleton of M, and assuming that the kernel has no errors, that's not true in general, but assume that errors may occur only in the concurrent process. How can you solve that? Just decide which are the primitive signals, syscalls, and how to do. So just in words. And that's the first problem. So I ask you to work on this in groups and write this. I want to publish also solution, because there's not one solution for that. There are tens of possible solutions using different primitives in POSIX and so on. So it's a good idea to show possible solutions. So I'm strongly asking you to work on this 15 minutes in groups, then to take at home, but I want to publish a result. If you don't give me something to show to other students, I will do, but I hope that you will. Okay, this is one of the two problems that are already in our web. So you can stop share, okay. You can find there. Questions about this problem?
I have a quick question. The individual processes, we can assume to modify them as we like, or should they be completely transparent to what the master does?
No. The processes are running. Somebody else has written the processes, so you cannot do. You must discover if they are computing.
Okay, but we assume that we do not know anything about the processing, about what they are inside. Okay.
You're all interested in the fact that they are going on. They use resources. if you find any time that the processes are all stuck in, are sleepy, they cannot, for a given time, okay, do the recovery action. This is a really important problem that must always be implemented in every real system. So go on, 15 minutes. Well, I have to allow you sharing the screen. Okay. Okay, welcome back. Hope you have discussed it and we have find some solution on some proposal for that. Now we face the second problem, but I keep on suggesting you at home to sketch in some, using the technique that you prefer, sketch the solution using drawings and a list of components and or everything, just to describe the specification for a possible solution, in not arriving to writing a code for doing that, but just exactly describing the solution of the problem. And the same we will do with the second problem, that is also in this case a very common, normal problem when developing a concurrent real-time algorithm in general. So the second problem has to do with the idea of implementing process scheduling not inside the kernel. The kernel is just a support. Suppose you have granularity less than the scheduling granularity of the kernel. The kernel usually schedules processes at few milliseconds. Suppose that you have to schedule processes to 1 second or more, but you have to do that. And this is a general framework that in many cases you must able to solve. So I will share the screen again. Okay, this was the previous drawing. Let me depict the second one. I guess if the recording is on, I think so. Yeah, it's on. Well, the second problem is scheduling. As the previous exercise, the idea is just to sketch a solution in terms of primitives of just a few words defining the algorithm, so on. Suppose you have several user processes. All processes are owned by you. Well, before, no, just I. You are a user. Well, okay, with combs in your hair. And there is the scheduler is a process, and you are talking with this process. The process acts on, the scheduling process acts and with all your processes with some simplified specifications. So PI are CPU bound, as to say, they simply carry out some computation, no input output, doesn't matter. So they compute for a while, I don't know, and then not cyclic, or in general, they can. So for example, in that case, the user has a command that is run process I with a priority, a certain priority. What does it mean? You must implement in words a round robin scheduler. So exactly the Unix scheduler we have discussed it in the organization, the architecture of the Unix architecture, the first pack of slides, or first or second, I don't remember. So it's based on the idea of having a base priority, that is the priority that you have given to the process that you want to run, and the actual priority, go back to the slides, and so you will remember which is the algorithm, the round robin algorithm. The actual priority is based on the CPU time. On the CPU time consumed. So that each process starts running with that certain priority, then priority decreases as long as it uses the CPU. And S manages the scaling. So the quantum, in this case, quantum of the scheduler, of the S scheduler, is much higher than the quantum of the internal scheduler of the kernel. So they're not in conflict. So from the point of view of S, all processes are running simultaneously. Quantum high. How to solve this? Which are the primitives? Signals. Which signals? Surely you must need you need signals. You must keep an array, a list of processes, and use signals to activate. So I can simply say that the solution is based on use POSIX signals. Use POSIX signals. Signals in general may be very powerful, but they're not used for concurrency, for exchanging information. So just for a few purposes, and this is the main purposes of signals just to do something similar to a scheduling of processes. You can stop and go. How? How using positive signals, and which primitives were related syscalls? System call. There are several syscalls that generate signals, for example, alarm. Oh, okay. So that's the problem. It's a real problem, like the previous one, and is part of the game for a robotician programmer or a designer or of software architecture for robotics. Okay, stop share. You find this in a similar way on our web, and please use the last time in our class to do the same.